1, 2, unité, feu.
370 million gone in 40 seconds. The engines were fine, the fuel was perfect. This catastrophe happened because of a wrong assumption about how a number should be represented inside a system.
Hi, I'm Wahid, and welcome to session 3 of Foundations of Data Storytelling. In the last session, we talked about choosing our variables. But once you know what you are measuring, the next critical step is deciding how to represent it. Choosing a data type isn't just a technicality. It's about defining the identity of your data. Today, we are building a 3-step roadmap to ensure the data types you choose actually support the story you are trying to tell and don't lead to a 370 million disaster. Before we dive into step 1, I want to give you a quick heads up on how this roadmap is structured. Every step has 3 parts: the introduction, the simple example, and finally, the real-world data cases. Now, if you are just starting your data journey, that third part might feel a bit intense or heavy with technical jargon. If it feels like too much right now, don't worry, it's totally fine to skip it and move to the next step. But here is my advice. Even if you don't catch every single detail, just let it play. Listen to it. I'll give you a feel for how data actually behaves in the real world and prime your brain for what's coming next. But again, no pressure. Work at your own pace. Stage 1 is the identity test. Ask yourself one simple question. Am I dealing with a label or a quantity? Take gender. That's a label. You can't add or subtract it. There is no mass hiding there. This is categorical data. Now take income. That's a quantity. The numbers actually matter, and the math makes sense. This is numerical data. If you fail this test, every calculation you do later will be meaningless. But here is the pro tip. You might also hear these called qualitative and quantitative. Don't let the big words confuse you. It's the exact same thing. But here is where it gets really interesting. Age on the surface. Age is just a number, right? A quantity. And most of the time, that's how we treat it. But sometimes the actual number doesn't matter as much as the label it represents. Like child vs adult. Think about it. If you are a doctor studying growth hormones, you need every single year and month. The exact age is your data. But if you are a movie theater owner or an app developer, you might only care about one thing. Is this person a minor or not? You don't care if they are 25 or 45. You just care that you are in the adult category for legal or pricing reasons. The variable, the age, didn't change. Your goal did. This is a huge lesson in data. Before you decide how to measure something, you have to ask yourself, what decision am I actually trying to make? Think about credit scores. Most people see them as just a number, but for banks, it's like a financial report card. It tells them if you are a safe bet or a total risk. Usually, these scores range from 300 to 850. But here is the trap. Is the risk difference between 700 and 710 the same as 800 and 810? The answer is no. In the real world, risk isn't linear. Moving from bad to average is a completely different story than moving from good to excellent. That's why, when we are doing serious data analysis, we don't just treat these as simple numbers, we treat them as categories. or what we call factors in R. It's just a way to tell the computer that the order and the context matter. This is exactly how you start thinking like a real data analyst, by seeing the story behind the number. Then we have the Likert scale. You know, those surveys where you pick anything from strongly disagree to strongly agree. Most people make the mistake of just averaging the results. But think about it. Is the mental gap between neutral and agree really the same as the gap between agree and strongly agree? Probably not. Feelings don't have equal distances like centimeters on a ruler. That's why for a single question, a simple average can actually be misleading. Professional analysts often use the median instead, or specialized models for ordered data. You only start averaging when you have combined a whole set of related questions into one big score. Knowing exactly where to draw that line? That's what separates a beginner from a pro. Stage 2 is the structure test. If your variable is a label, ask, does the order matter? Gender? No order. That's nominal. Education level? Order matters. That's ordinal. If your variable is a quantity, ask, can this value live between whole numbers? Counting people? No. Discrete. Measuring weight or time? Yes. Continuous. Textbooks make all this sound so easy, but in the real world, data loves to play tricks on you. Take zip codes for example. They look like simple labels, nominal data, right? But they are not just random numbers. They often hide a geographic hierarchy. The first few digits can tell you exactly which region or state you are dealing with. There is a hidden order there if you know where to look. Think about weight. It's truly continuous. If you go from 70 to 71, you must have passed through every single decimal in between. Your body doesn't just skip numbers. But look at high-frequency trading. In this world, we often treat time and price as discrete. Why? Because in high-frequency trading, if a stock jumps from $100 to $105 in a millisecond, treating that as a smooth, continuous line is actually a mistake. You would be making up trades at 102 that never actually happened. There was no buyer, no seller, and no price at that level. In these high-speed markets, assuming the data is continuous leads to huge calculation errors. You have to respect the gaps between the ticks. My point is, don't just trust the surface. Trust the context of your problem. Real data analysis is about knowing when to see the flow and when to see the steps. Stage 3 is where things get dangerous. I call it the representation and risk check. This is exactly where the Ariane 5 rocket failed. They traded precision for simplicity, trying to cram a 64-bit number into a 16-bit space. That's a small simplification led to a 370 million explosion. But sometimes we simplify data on purpose for ethical reasons, taking on top coding. To protect people's privacy and keep the data anonymous, researchers often cap incomes. For example, anyone earning over $150,000 is just labeled as 150K plus. This is a moral choice, protecting identity, but it comes with a technical price. The moment you do this, you lose the ability to distinguish between a high earner and a billionaire. You have traded your ratio data for ordinal labels. Every time you simplify, whether it's for privacy or just turning age into young vs old, you are throwing away information. Sometimes that loss is a noble sacrifice for ethics, and sometimes it's a fatal mistakes. So the real question isn't, is this data type allowed? It's, can my project afford this loss? And is the trade-off worth it? Knowing the price of that loss is what makes you a pro. Some people ask me, why aren't we coding yet? Every other course starts with R or Python on day 1. Here is my answer. Learning syntax is easy, but learning to think is where the money is. I've seen too many people write perfect code that produces worthless results. In R, your code might run perfectly, even when your logic is completely wrong. The console won't scream at you. It won't give you a red warning if you treat a credit score as a simple number instead of a risk factor. That's why choosing the right data type isn't about memorizing syntax. It's about being a responsible analyst. If you don't understand the why behind the data, the how doesn't matter. So don't trust the code first. Trust your reasoning. You are building your brain as a tool first. The software is just execution. Now, just like in the previous video, I've designed 3 real-world challenges for you in the description below. One for psychology, one for finance, and one general case study. You know the drill. Choose your route, pick the one that aligns with your career goals. These tasks are the building blocks of your professional portfolio. We are moving toward session 15, where you will start building your actual projects. If you don't master the logic now, you won't have a solid portfolio to show an employer later. So take this seriously. To submit your work and get my review, you can use the Telegram channel, comments, or send it via email. I will be personally reading your logic, not just your answer, and providing feedback to make sure your reasoning is sharp enough to keep that rocket flying. Let's get to work.